So lecture 3, polymers, non-biodegradable and biodegradable polymers. Now non-biodegradable are nothing but the synthetic polymers. Synthetic polymers are resistant to environmental degradation. That is the non-biodegradable polymers. That is those synthetic polymers which are resistant to environmental degradation and are accumulated as solid waste material. That is, they are never completely decomposed. They get accumulated as solid waste material. And these are nothing but the non-biodegradable polymers. So what we need a lot of efforts from the mankind to prepare biodegradable polymers, and some of them which we need to know in as per our syllabus are the three. One is the PHBV, and then is the Dextrin, and then we have got Nylon 2, Nylon 6. Okay. So the first one which we are making is PHBV. What am I doing? I'm making a biodegradable or I'm making a non-biodegradable?
Biodegradable.
Yeah. So the biodegradable polymer which I'm making is PHBV polymer. That is the PHBV polymer. Anyone can tell me full form of PHBV polymer?
Polybeta hydroxy butyrate,
Yeah.
co-beta hydroxy valerate.
Very good. देख के बोल रहे हो ना?
नहीं मैम, मेरा
Okay. Polyhydroxy butyrate. Co this co is cobalt?
No.
Or carbon monoxide?
None.
What it is? Carbon monoxide?
No.
Then what it is?
Copolymer.
Yes, it's a copolymer of hydroxybutyrate, that is 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. Okay, it is a copolymer. That is why that co. Okay. And the monomers are 3-hydroxybutanoic acid. What I said?
3-hydroxybutanoic acid.
3-hydroxybutanoic acid. Three-hydroxybutanoic acid and 3-hydroxypentanoic acid. You should keep on learning. During the lecture only you should learn. 3-hydroxypentanoic acid. So you have to learn PHBV polymer. It is a polyhydroxybutyrate, a copolymer with beta hydroxyvalerate. It is a copolymer and its monomers are 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. And it is having an ester linkage. So it's an ester. And otherwise also वो जो 8 है 8 से समझ आ ही रहा था कि एक ester है. Yes or no?
Yes, ma'am.
Now I am making the polymer. Be very attentive now. I'll give you a nice trick. See, first just recollect the basics of forming an ester. Whenever you are making an ester, it is the reaction of an acid with an alcohol, where as a student you should keep in your mind that acid gives OH and alcohol gives H. Now if you look carefully, this hydroxy is the alcoholic group and this oic acid is the acid group. So this acid group will combine with this hydroxy, where the acid group will lose OH and the hydroxy group will lose the H. And same way pentanoic acid with the next hydroxy. Are you getting me?
Yes, ma'am.
Now I'm making the polymer, okay? Be attentive. 3-hydroxybutanoic. So butanoic, 1, 2, 3. 1, 2, 3. Butanoic, see what is being smart and what is being not smart. Now writing like this is not smart. Plus, see what I'm doing now. 1, 2, 3, 4, 5. Acid. And 1, 2, 3. 3 pe hydrox. Now writing like this is not smartness. This is how you people write. This is just not being smart. Because here you will have maximum problem in understanding how this OH and this H goes. So instead of that, what is smartness? Remove it from here, remove this from here, and write it vice versa. That is, write the chhatri here, because as such bond तो बनाने का नहीं है अपने को छतरी के साथ, अपने को तो OH के साथ बनाना है. Same way write the chatu chhatri there, क्योंकि bond तो वैसे भी OH के साथ बनाना है. Keep OH free in your bonding region. Do you understand? So this OH and this H goes, and this OH and this H goes. Do you understand what I did or tucked in a din?
Yes, ma'am.
tucked in a din हो गया?
समझा.
बस
समझा, ma'am.
अभी इसको लिखने का dash O CH CH3 CH2 CO dash O. This is the ester linkage. Dash CH CH2 CH3 CH2 CH2 C. बहुत ज्यादा हो गया, तुम बोलता नहीं? अरे भाई 5 ही तो है. Okay. CO dash and N. So this is polyhydroxybutyrate co-beta hydroxyvalerate. Is it clear?
Yes, ma'am. Yes, ma'am.
देखो एक थोड़ा सा लिखने का ढंग सही है तो कितना आसान हुआ, but otherwise it was difficult. Yes or no?
Yes, ma'am.
Okay, so that's pH. Now we proceed further. Taking the second one. Second one which we are making is Dextrin or Dextron. Again, you should just know the main things. and that is, it is polyglycolic acid and polylactic acid polymer. Okay, polyglycolic acid and polylactic acid polymer. Monomers are common sense. The monomers will be glycolic acid. Yep,
Yes, ma'am.
and lactic acid. So it is also a copolymer, and it is also having a ester linkage. Now, what is glycolic acid? Glycolic acid is basically 2-hydroxy ethanoic acid. Okay, and lactic acid is, anyone knows? Because lactic acid you have done in D and L isomers. 2-hydroxy propanoic acid. कुछ भी नहीं है अभी. Let us, we have to just make the structure how an ester is formed. So lactic acid is 2-hydroxy propanoic. So being smart, I will write prop like this. I'll take chhatri up. And hydroxy I will write here because I know I have to make the bond. Same way, glycolic is 2-hydroxy ethanoic. So this is not at all difficult because only 2 carbons are there. Is this clear?
Yes, ma'am.
Now, if you just lose a molecule of water, acid will give OH, and alcohol will give H, alcohol will give H, and acid will give OH. Now we will get dash O. You can say with me, CH up CH3
CH3. C double bond.
O O,
O.
then a
CH2.
CH2 and a C
C double bond.
double bond O and a dash and
Dash.
tring and the
N.
twing N. And what's this? This is Dextrin. Clear or no?
Yes.
Can you tell me what will be the byproduct? इधर क्या निकलेगा?
Water.
अब तो मैंने लिख दिया. Okay. Do you want to write? Shall I wait?
Yes, ma'am.
इसके पहले वाला लिख लिया or you want me to go to that page?
पहले
Okay, please complete this. Please tell me once you are done.
Done, ma'am.
Ma'am, 1 minute.
Done, beta? Please tell me.
Done, ma'am.
What you are saying, I can't understand you.
Done, ma'am.
Done, ma'am.
Okay. Now, what is the third one?
Nylon
Nylon 2, nylon.
Nylon 2, nylon 6. Now, it is a copolymer. नाम से ही समझ रहा है. Johan, do you know what is a copolymer?
Polymer, two or more monomers.
Huh?
Two or more monomers.
Yeah, different ones.
Yeah.
Okay. It is having polyamide linkage. What were the linkages in PHBB and Dextrin, Juhi?
Ester.
Yes. Same with this has polyamide linkage. What is an amide linkage, Prithvi?
Dash C double bond O NH.
Okay.
Dash.
Some nice food is cooking at your home. So dash C double bond O dash NH dash. And the monomers are, what are the monomers, Mehek?
Glycine and epsilon aminocaproic acid.
Glycine and epsilon. That is 6 amino. Six amino caproic acid. Now understand the basic of it. That is how a amide linkage is formed. The COH of acid and the H of amino group combine like this, and what is resulting is the amide linkage, which is this. This is the amide linkage. Is this clear?
Yes, ma'am.
Now I am making it here, okay? Now you all know what is glycine. The only alpha amino acid which is not having a chiral carbon. 6 amino caproic. Caproic means 6 carbons. 1, 2, 3. You know, in acid, we have to count the carboxyl carbon also as one of the carbon. 4, 5, 6, and a NH2. Now, what happens is, Gaia. Same thing here. And same thing here. So what we get is H, N, CH2, CO, NH, CH2 5, all I've written together, that is these 5, and a CO. Is it clear?
Yes, ma'am.
So these were the 3 main biodegradable polymers, that is PHBV, Dextrin, and Nylon 2, Nylon 6. These biodegradable polymers are used as for the orthopedic work, that is implants, sutures, drug release matrices, etc. With this, we completed all the methods of preparations of polymers.